35.1, isolating terms and formulas. Here, we want to isolate this r here. So this tells us what we're isolating, r. Now, in order to get r by itself, what has to happen is this. There's a multiplying 4, a multiplying pi, and a square. So we'll have to get rid of these step by step. Okay, both of these are multiplying, so they can be gotten rid of by using the opposite, which is division. So what we're going to do is get rid of these two first, and we'll be left with r squared. And then we're going to get rid of the square, and we're down to r. So that's going to be our order. We're going to get rid of the multiplying terms first, and then once they're gone, then we're going to get rid of the square, and then we'll be left with r equals. So a equals 4 pi r squared. The way that we get rid of a multiplying terms, 4 times pi, is by using division. So let's rewrite our and use division. So we use a dividing 4 and a dividing pi. And what we do to one side, you do to the other. So we divide a by 4 and pi. And then what we get there is an a divided by 4 and pi equals this r squared. Now from here, we're going to get rid of the r squared by taking the square root of both sides. So let's take the square root of both sides. Square root here, square root here. And this term becomes just r, like we were planning. And this means that we're taking this whole expression, putting it over here. This will be the square root of the a over 4 pi. And this will simplify down to just an r. And now r is simplified. Okay, for the next one, we're solving for c, so we want to isolate the c. Now what's going on with c? There's a plus b plus c, and then there's division of a 3. Okay, as we work this out, the order, we're going to get rid of the division first, the dividing 3, so we can use multiplying 3. So when 3 goes away, we'll be left with a plus b plus c. From there, we can get rid of the a term, and we'll be left with b plus c, and then we'll get rid of the b term, we'll be left with c. So that's the order. We're going to go for the 3 first, then the a, then the b, and we'll be left with c. So a equals a plus b plus c all over 3. And this is a dividing 3, so to get rid of a dividing 3, we're going to use a multiplying 3. So let's write the problem again. And we're going to use a multiplying 3 here and a multiplying 3 on the other side. So we'll end up with a 3a equals a plus b plus c. Then there's no 3. Now, let's get rid of the a. This a right here is an adding a. It will be adding to the c, so we need to subtract it from this side. So subtracting a here, subtracting a here. Now since these are not like terms, they can't subtract from each other, so they can only sit next to each other. So 3a and a subtracting a would equal b plus c. Okay, next we want to get rid of the b. So I'm going to use a subtracting b on both sides. Okay, and since none of these are like terms, we'll just sit all 3 of these next to each other. So we'll have the 3a, the minus a, and the minus b. And that will equal, this cancels, and the c is left. And that's c isolated. Okay, next. For this expression, a equals k times the expression b plus c plus d. Now, all of these terms right here, we're going after b right here, but everything in here is being held by k, by this quantity here. So it means once k is gone, all this is open. Okay. So we have a equals k, b plus c plus d. Okay, first we're going to get rid of the k, and that will give us b plus c plus d. There'll no longer need for the parentheses because the k is gone. Then we can get rid of two terms. We can get rid of the adding c and the adding d, and we're left with just b. So that'll be order. Get rid of k, then b and d, and we'll be left with c and d, and we're left with b. So to get rid of the k, that's a multiplying k, we're going to use a dividing k. So let's write that expression again. K, b plus c plus d. I'm going to use a dividing k. And what we do to one side, we do to the other. So that's another dividing k. So what we have now is an a divided by k. The k's are gone. We have a b plus c plus d. All right. So now we want to get rid of the c, the adding c and the adding d. We're going to do that by subtraction. Subtract the c and subtract the d. And what will be left, once these two are gone, is only the b on the left side. But whatever you do to one side, you do to the other. So I put a subtracting c and a subtracting d for the left side as well. Now, these three are not like terms, so we simply put them next to each other. I'll put a over k first, then the subtracting c, then the subtracting d, and we're done.